Hi there, my name is Tim Cruse. I'm a Principal IoT Specialist Solutions Architect here at Amazon Web Services. And I'm so glad to have you joining us today for this online version of our summit. This particular session, Industrial Machine Performance Insights with AWS IoT, is intended to show you how to connect your industrial equipment to the cloud, ingest data, and then calculate from that data performance metrics and display them in dashboards. This is a hands-on session where in the second part of this presentation, I will dive into the AWS Management Console and show you how all of this works. For this session, I thought I'd provide you all with a bit of brief background as to the difference between consumer-based IoT workloads and industrial IoT workloads. There are a couple key differences for which usage of specific services make more sense than others. We'll cover 3 of those specific services for industrial workloads, and then we'll talk about our demo use case before diving into the demo. Are you ready? One of the first things I'd like you to take away from this presentation, especially if you haven't heard this from me or my colleagues before, is that despite this presentation being about the Internet of Things, in an industrial context, no one buys IoT. IoT is not a solution. It is not an application you can purchase or get a license for. What customers seek are business outcomes. I'll even add successful business outcomes. Customers want to improve their products, improve their efficiency, reduce wastage, or simply have better knowledge of their environment. And the Internet of Things is one of the strategies that allows these customers to be successful in achieving these business goals. In the context of industrial workloads, yield, efficiency, waste reductions, optimizations are key topics on business agendas. In these challenging times, remote monitoring of assets is becoming ever more important. Remote monitoring securely, at scale, to drive better business insights. When we talk about business goals and successful outcomes with customers, we generally see the following 2 main topics or axes. On one dimension, customers are looking to grow their revenue. Their strategies will revolve around the creation of new services and business models. Knowing how your product is being used on a daily basis allows you to improve your next generation product, as well as update existing product lines with new capabilities and features remotely. Better connected products inherently creates an intimate relationship between your brand and your customers. Customers aren't acquiring products anymore. They're acquiring easier lifestyles. My white goods are now connected, and not only do I have to not worry about maintenance anymore because the manufacturer sends a technician over to fix something before it actually occurs, but the device reduces the friction with my routines by adapting to it. The bar in 2020 is set. Almost every new consumer electronic device being designed today fits within a connected ecosystem, even if just to upgrade the firmware by connecting it to your mobile phone. On the other spectrum, customers are challenged with needing to improve their efficiency. These devices need to be produced at larger scales, and the friction in the manufacturing processes need to reduce. Efficiency needs to increase, machine downtime needs to be reduced. If I know everything about my machine at a given point in time, and I correlate that to historical data, I can start modeling potential upcoming failures on that machine. Predictive maintenance is a hot topic. With the right data at scale and properly processed, I can make the right business decisions. Both these 2 axes and business goals are enabled with robust, secure, and scalable IoT strategies. IoT connects your devices, adding smarter capabilities that improve over time and bring you closer to your end consumers. IoT connects your industrial equipment, ingests large volumes of data to build predictive maintenance models, and improve live monitoring of assets, sites, and whole ecosystems. This is why at AWS, we've been investing over the past 4 years into designing managed, scalable, and secure services to remove the heavy lifting of managing your IoT devices and fleet. A flywheel of services allowing to extract data and control devices, manage them at scale, and apply analytics to that data at scale. In this presentation, and to serve our specific industrial use case, we'll talk about AWS IoT Green Grass, AWS IoT Core, and AWS IoT Sitewise. AWS IoT Core is a fully managed connectivity broker for your devices. A service designed around multiple pillars. It's an identity service, All your devices are uniquely identified on the broker and giving you fine-grained control over what a device can or cannot do. Each device needs to authenticate itself to the broker with X509 certificates, and data to and from the device is protected with TLS 1.2 encryption. It's a fully managed and scalable device gateway. Whether you want to connect one device or a million devices, the gateway will scale accordingly. It's a managed MQTT message broker supporting pub/sub messaging to and from your devices. You can subscribe to specific topics and publish data to others. Once your devices are connecting to the broker and sending data, the rules engine and the device shadows allow for transmission of that data to other services, as well as manage the state of your device in the cloud, allowing your applications to interact with your devices even when they are offline. AWS IoT Core is a central part of our industrial data ingestion, responsible for ingesting an extreme amount of data at scale for as many devices you choose, but also passing this data on to other services. AWS IoT Green Grass. Green Grass is one of the edge-level services we provide, allowing to connect to IoT Core to send data to the cloud. Green Grass is software you can install on any Linux gateway. It actually extends IoT Core's capabilities down to the edge, closer to your devices and equipment. It's a local pub/sub message broker supporting local device shadows. It supports the execution of Lambda function as well as Docker containers. Your Lambda function code gets deployed on the edge and will run at the edge, triggered by the different messages flowing through the broker. It implements the same level of TLS 1.2 and X509 authentication requirements as IoT Core, and supports the execution of pre-trained machine learning models at the edge. With a growing list of connectors, Green Grass can be extended to support local connection to all sorts of industrial protocols. And this is where Green Grass plays a key role in our industrial applications. Installed on industrial gateways close to your industrial equipment, we can extract machine data over industrial protocols like OPC UA and transfer this data to the cloud. Once our edge device sends data to the cloud and into IoT Core, thanks to IoT Green Grass and the Sitewise connector, we can now leverage AWS IoT Sitewise to help monitor our industrial assets. Sitewise is a managed service that allows for managing local edge industrial gateways, displaying customized views to monitor your assets and allowing you to create models of your assets and their data. By managing your edge gateways, you'll be able to access data from local databases or equipment on your factory floor. You can read data from aggregators such as historian databases across all sites and store your data in the cloud. The Sitewise connector in Green Grass allows for caching of data locally in cases where there is intermittent internet connectivity. Effectively, Sitewise connects via Green Grass to your equipment and allows reading of the data from industrial protocols and sends it to the cloud. The data management and modeling tools within Sitewise allow you to create models on which you derive your assets. Models, in effect, are going to be your type of assets. Obviously, a generator will be very different to an HVAC or a conveyor belt, each having their own data and metrics. Sitewise will create indexes to the types of raw data, derive metrics and transformations of that data to allow the creation of specific performance metrics and measurements for each of your different assets. Once you have created models for the different type of industrial equipment you have within your facilities, you can then derive as many assets of those model types that you own. Your facilities may have 2 generators, 4 conveyor belts, and 3 HVACs, for example. That's 3 different models. And you could even create a facility model encompassing your facility. With model hierarchies, you can start modeling your individual assets all the way up to your factories and your global footprint. The previous modeling of assets and transformations to the raw data allow for the creation of data sets representing your different assets. With Sitewise Monitoring, you can visualize this data coming from your equipment. Monitor the raw data or the performance metrics you've chosen to calculate and display them on graphs over time. No need to query specific data streams. Data gets aggregated and rolled up logically under your asset models. You can very quickly develop operational dashboards to show this data in almost real time to your organization. A dashboard could provide you with detailed performance and runtime view of your assets, whilst another one could simply provide other stakeholders in your organization with performance metrics of the plan itself in aggregated form. Once you've modeled your different assets and started to deploy your gateways inside your industrial environments, the data will start flowing logically, allowing you to have remote visibility into your equipment and business. Whether you're a system administrator, a subject matter expert, or a production manager, the monitoring capabilities of Sitewise will allow you to improve your operations significantly and reduce time and cost of managing such complex industrial infrastructures for equipment data. System administrators will want to have granular control into how Sitewise collects the data and how they can customize the different views and dashboards. Industrial subject matter experts will want to model the data, shape it, transform it in close to real time and create performance measurements from the raw machine data. They'll want the ability to explore all assets across all your different sites. Production managers will be able to quickly view operational metrics, diagnostics, and workflows from their facilities, effectively reducing the friction in visualizing and unlocking the data from your equipment for your business. From a technical perspective, in summary, if we follow the data from our devices to the cloud, the AWS IoT Sitewise Gateway runs on AWS IoT Green Grass on your device. The Sitewise Gateway is a connector that you simply add to your Green Grass group. Green Grass runs on your industrial gateway in your facilities, close to your machines, and will connect to your OPC UA servers. Once connected and running, Green Grass will connect to AWS IoT Core, resulting in the Sitewise Gateway sending MQTT messages to IoT Core on dedicated Sitewise topics. At this point, data from your assets is flowing into the cloud into AWS IoT Core. To start analyzing this data and associating it to your different assets, an IoT Core rule can be used to forward this data to AWS IoT Sitewise. In Sitewise, you'll create models, derive assets, and visualize the data from your assets. As a final note, Sitewise can also be configured to publish transform data and metrics back out over MQTT to AWS IoT Core. This is extremely powerful if you want to archive this data or forward it on to other business applications. Easy, right? Now let's have a look at what this will look like in action. Now for this demo, unfortunately, I don't have a full industrial facility I can play with, but I'm working on it. So for the purpose of this presentation, I'll be simulating our industrial environment and the production of data. And do note that the following demo is actually part of a really great workshop that one of my colleagues, Philippe Sacha, has prepared that you can run today in your own AWS accounts. So you can also play around with Sitewise. Do reach out to your local AWS teams so they can help you run this workshop with your teams. Now back to our demo. What we'll be monitoring is 3 power plants. Each one of our power plant will have power generators, 2 in each power plant. These generators obviously produce electricity, but they report data. They report energy production, temperature, and rotations per minute. We'll acquire this data, send it to the cloud, and we'll want to visualize it. We'll also want to transform it so that we can calculate and visualize the overall equipment efficiency, or OEE. Now, for those of you who aren't familiar with OEE, it's a simple indicator of the performance of our equipment. I actually looked up the definition, and I quote, "OEE is the gold standard for measuring manufacturing productivity. Simply put, it identifies the percentage of manufacturing time that is truly productive. An OEE score of 100% means you are manufacturing only good parts as fast as possible with no stop time." To calculate OEE, we measure our equipment's availability, performance, and quality, each on a score of 100%, which we then multiply. We'll then want to measure the number of good parts produced over the total parts produced to define our quality. Then, we'll measure the actual throughput over the expected throughput for performance, and finally, we'll measure our equipment's runtime over the total runtime. For example, your machine may be producing 100% good parts at full speed. However, if you only turned it on half of the time, your OEE will be of 50%. Is that clear? Okay, so let's dive into the console and start measuring some OEE. First of all, let's log into the AWS Management Console. For the purpose of this demo, we'll be using an EC2 instance on which we are running a Cloud9 environment. This environment will host different scripts as well as an installation of Green Grass to simulate the capturing of machine data. It is from this instance that we will be generating data for the 6 generators. We would first create a Green Grass group with the Sitewise connector, and we would deploy that group onto our gateway. In the Green Grass Management Console, we can find our group. I've already created the Sitewise group here. Its group ID is 37586, and so on. And we can see that we've configured it with the Sitewise connector. And it is deployed. So far, so good. Now, let's have a look at our EC2 Cloud9 environment and see if our data is flowing in correctly. Here, you can see our Cloud9 environment. I've got 4 tabs open. This tab shows me that Green Grass is running. This tab shows me that the script generating data for generator 1 and 2 is running. And for the purpose of this workshop material, generator 1 and 2 are simulated with the OPC UA local server, and we'll configure the Green Grass Sitewise gateway to connect to that OPC UA server to extract the data. This tab generates data for generators 3 and 4, and for this, we are sending data directly to AWS IoT Core. And this final tab generates data for generators 5 and 6, for which we have chosen, for the purpose of this lab, to use the Sitewise API, allowing us to ingest data directly into Sitewise. There's not much to see here, but at least we know our data is being generated and being sent. Let's go see in IoT Core if we are receiving the data. The Sitewise connector sends data onto a reserved $AWS/Sitewise topic. Unfortunately, we cannot subscribe to this topic, and so we'll simply create a republish rule to the AWS/Sitewise topic to see the data coming in. Here's our rule. You can see it's a republish rule to AWS/Sitewise and passes the fields from the $AWS Sitewise topics, as well as providing me with some indication as to which topic it was sent on. If I connect to the AWS MQTT web client here and subscribe to the AWS/Sitewise topic, we'll see our data flowing here. So far, so good. Our data is flowing into Sitewise. Now, let's go have a look at the AWS IoT Sitewise console. The first thing you'll want to do when setting up Sitewise is create a gateway and link that gateway to your Green Grass group. Here's my gateway, and we can see that it's linked to my Green Grass group with the same ID, 37586, etc. As to the source of the data, we can see that we are connecting over OPC UA protocol and configured it for the local host address on port 26543. For this demo, that's all we need. Now this will configure our Sitewise gateway to connect to the local host OPC UA server generating data for generator 1 and 2. We'll need now to create models for our different assets. Remember, from our story, we want 3 types of models: generators, power plants, and an aggregate view of our power plants. So we'll start by creating a model for our generators. Our generators will have a unique serial number attribute. The raw data measurements will be the RPM, watts measured every minute, and temperature. We'll want to transform those measurements into performance metrics. We'll create a good power value by transforming the watt value into binary good or bad value if the power is greater than 15 watts. Note that our perfect power rating will be of 25. With our transformation created, we can now create metrics for our generator. These metrics will help us create the OEE value we are looking for. For example, we can get the quality value every 5 minutes in the form of the sum of good power value over the number of good values. The performance value will be the sum of our minute measurement of power over 5 times our maximum power of 25. Availability will be calculated by measuring the amount of time within the 5 minutes that we are producing power above 15 watts of power. Finally, our OEE value for that generator will be the multiplication of availability, performance, and quality. Our power plants will be created in similar fashion. They have a location in terms of GPS coordinates for attributes. They don't have any measurements or transformations. However, what we'll be interested in is deriving metric from its child assets. Here, we'll want to derive the plant's OEE value calculated as the sum of the different child's OEEs over the number of assets. And we create a hierarchy definition by having the power plants be parents to generators. Finally, we'll create an overarching model for our power plants, which really only has a derived metric of sum of the power for all our power plants and a top-level hierarchy over power plants. Now that we've set up our models, we'll add assets and bind the message topics coming from the individual assets to the different measurements. Given I've already set this up, let's have a first look at generator 1, for example. You can see that generator 1 is a second-level child to the all power plants asset and the power plant 1. If I edit generator 1, we can see how it is set up. I've given it a serial number of 1234. Its RPM, power, and temperature values are taken from the OPC UA topics /day1 energy core /1 for my generator 1 /generator /RPM, power, and temperature, respectively. The notification status dropdown allows me to configure whether or not I want Sitewise to export the data out of Sitewise back into IoT Core. This is how you would create your different assets. You can see that I've created 6 generators. The association of assets to power plants and power plants to the all power plants asset is simply done by creating those individual assets and then associating the child assets. For example, I can create a test power plant, then I can edit it, and associate generator 1 to it if I want. If we look at, say, power plant 1 now, we can have a look at its metrics and see that the calculations get automatically populated as the data flows into generator 1 and generator 2. This is now perfect. My data is flowing in, and I'm now measuring OEE data for my generators and my power plants. But I'm not finished. Ideally, it would be great to visualize the data. For this, Sitewise has Sitewise Monitor that allows me to generate portals. These portals will host dashboards that you can configure with the data you wish to see. First of all, let's have a look at the OEE dashboard I've prepared already for our power plants. You can see I'm now displaying in somewhat real time the OEE values for each of my power plants, P1, P2, and P3. Since I'm calculating OEE every 5 minutes, the data will only change then. Let's not wait. Let's have a bit of fun and create a new dashboard. Let's say I want to visualize temperature and RPM for generator 1. All I have to do is drag and drop those measurements and metrics from the assets into the dashboard. And you can see I now have a graph showing me this data. If I'm interested in the OEE for generator 1, I can take the OE value and display it as a graph or as a value. As you can see, Sitewise Monitor makes it extremely easy for you to navigate in your data and create the dashboards you want for your equipment. A great tool. And with exporting of data through the notification status, you can then create flows where the transformed and calculated data comes back into IoT Core so you can pass it onto your other business applications. There we have it. I really hope you found this session useful and allowed you to understand how AWS can help you monitor and improve your efficiency in industrial context. Do reach out to us so we can help you start monitoring your industrial environments, and hope to be seeing you again real soon at our different events. Please do fill in the session feedback and survey. This helps us improve to meet your needs. Thank you, and have a great rest of your day.